Welcome to the ENVI tutorial series part 4, analyzing our results. In part 1, 2 and 3 we went through ENVI as how to simulate and how to model and what the models are composed of. Now in this part we will use the tool Leonardo to look at our results and try to understand some of the simulations we did. To begin with, before we go into our analysis, we just want to see if our simulation has performed correctly. We will go into the tutorial project, which were our defined folder structure to begin with. We will go into our simulation output folder and we will see that ENVI has created a whole set of folders. Among these there's a log folder, which you can read the log in which you can find details about the simulations. There is this atmosphere folder which we will use, and in here you will see that there are 24 simulation output files called EDX and EDT. These the Leonardo tool is using these files combined, so we need to have them collected here. And we can in theory just use one of these sets, but as we have all of these, we can actually use them and combine different analysis if you want to. Also, you might want to use different versions of your design. That is, for example, you have changed the height of a building or moved it to another place on the site, and then you will have different files in different folders. This is alright, and I will show you how you can actually open different folders and different files and compare these files. So first we'll start Leonardo. Leonardo is a software that can look into different types of file systems. Among these are the ENVI, and this part is kind of tweaked for that. So we'll start to go to the data navigator. This is located here, and we will select a file. I already put the path to this file, but you might do that manually here. You can choose any of these EDX files. It doesn't matter for now, because the Leonardo tool will load them all, placed in that folder. Now we can see it has understood that we have simulated from 8 in the morning to 7 or 6 in the morning from the 23rd to the 24th. We can take, for example, 12 o'clock and look at the 2D map. Often we want to visualize our data in 2D. We can do that by the 2D mapping method. First of all, we'll select the data in our dataset. In this case, I only want to show you the wind speed. We can make contours as well, or simple visualizations. For now, we just take ordinary or normal dataset, which is like a based graph or image-based visualization on each of these cells. We can change the vectors as well. For now, we'll just extract the wind speed. We'll take a second and then we'll update the legend and the file here. We'll see that the wind is represented as a speed from 0.34 to slightly below 3 meters per second. And as you remember, our initial condition of wind speed was 3 meters per second. So this fits well. In this panel we can either left click like this and here for the settings and the legend settings, or we can right click to switch the legend and the illustration off. Underneath here we can auto fit or set our initial value, that is the first value here, and the step size in which we want these amount of legend numbers to be represented in. So we can just have a step size of 0.25 and then update it, and this is slightly easier to read. So let's say we have a criteria, which we probably don't, but if we had a criteria of a certain area that shouldn't reach a velocity of wind conditions above, let's say 2.0, then we can actually see it very easily where our conditions are are not held. We can also visualize, as an example, our air temperature, extract 2D, and you will now see that it keeps the legend, and therefore it's kind of hard to see. We can just auto fit it, and we'll see that temperature ranges from 19 or something like that to 21, which also fits what we inputted in the simulation file. We can also see that the temperature is kind of larger in this area, and it's where the wind comes from. It seems slightly colder. I know that the wind comes from this direction, but we can actually visualize it because we have a flow vector, and we can visualize this with our vectors and particles. So in this tab and this tab we can see the vectors. We just right click it and you can see these small arrows. Just zoom in slightly. And each of these arrows represents the initial or the particular direction of wind in that field. And we can zoom in between our buildings and see which direction the wind actually goes. Okay, this is a little hard to control. So, alright. We can also use the particle trajectory settings, and I will show that in the 3D option later on. If you want to look at the changing time over the different simulations, we can just double click these and look at the changing temperature in our site here. But as you see, our legend is continuously auto-fitting. So to make some kind of evaluation that is making sense between these type of analysis, we need to stop the auto fitting. So in the afternoon we have a temperature around starting from 26 going up to 30 degrees, whereas in the morning it's starting around 20 degrees which is our set point, and ends up 22. So let's say that we want to fix our first value at 20 degrees, and we want 1 degree jump in 10 colors. We update that. This means in the morning we have like cold view, and then when we go to 10 o'clock the air temperature heats up gradually. 12 becomes hotter, and eventually quite hot summer day in the evening it will gradually go down again. So what is the temperature actually changing? And you can also see the buildings are heated up during the day, and here the surfaces are warmer in the evening. Of course, it's the sun that heats up the temperature, the air temperature, so we can also visualize the sun influx, also called direct radiation, and we can set that. And now you will see a very sharp edge this between under 21. No, we need to out-of-fit that between 90, or that is 0 radiation, and around 700 assigned radiation. And what you see is actually the direct sun hitting the ground. And if you overlay a picture of overlay the geometry, you will see that where the sun is hitting. So you can use this as a direct sun analysis. And we can also say, well, let's start at 0 without auto-fitting here. First value 0. And we'll want to end up around 1000 watts. So let's just make jumps of 100. And let's look at the different time in this data set. And we can see that the sun is actually changing position this way. And the shadow on the ground, which means that where we don't have any direct sun. It's kind of hard to see when we haven't got the overlay, but you need to do that manually. We also have an option to compare two file sets, not as two separate files as we just did before, but we can compare them in the same evaluation. We have only selected file set A here, but we could actually take the exact same file set that we used now and just change the time between these two files. So let's say file A is here 13 hours and file B might be 17 hours. This means that we can make a radiation comparison between these two. We just press this button, compare to D, and then this way we can see the amount of solar radiation hitting when comparing these two analyses. Of course, it doesn't make much sense to compare over time, but if you had two different design proposals, you can compare the two proposals in the same time with each other with this kind of overlay. The same thing can be done in all of these other elements. What might be interesting is the mean radiant temperature, and you will see here when I auto-fit that you can have a very large difference between the felt temperature between, let's say, two different designs. Of course, we have now chosen one just 1 o'clock, and the other one was in the afternoon, which means we have almost no radiation in this place in file set B, and that means the felt temperature is much lower, and this is of course very obviously seen here. The last thing I want to show you is the 3D map option, but before I do that, I just want you to keep in mind that you can change the position of your viewplane in this particular place. that's changing up and down, or you can visualize the other axes, like a cut through this site. The 3D map option has a little more advanced way to visualize that, but it can be a little more difficult to control than the 2D version. To start with, we extract 3D, and you will see this none remaining. You have no evaluation here. And what you need to do is to go to the data layer settings, turn it on, and then you will see an inside of your cube here. The way you control it is that you can set the range. Now we just have temperature, so in the range of 24 to 29 degrees. And we can adjust, for example, our set plane. This is the set direction up and down to, for example, 5 meters, and update that. This means we see all the cubes from 0 to 5 meters in from the x-axis 0 to 59 and the y-axis from 0 to 59. And we have this option to go up and down and out and visualize this way here. That's about it. So for example, if we change the height here, you can see the cut is more relevant in that direction. Also, we can cut it this direction also. Might be easier to see from here, maybe 25, 59. So we have that kind of a cut. This can be useful for some, for example, cut throughs instead of 2D planes. There's also an option to make a animated vector layer. This is called the particle trajectory settings. And what you can do is just play here. This is the wind direction, and the wind is coming from these vectors. And you can set other vectors, for example, the sun vectors. Here it makes more sense that you have the wind coming through. Let's say we have these buildings we're interested in here, and we might be able to zoom a little down. Height. So I need to do that. Maybe we need to stop this first. Yeah. Zoom in. And let's play it again. And we can actually see some particles coming out of this plane, as here. And we have any options to change the speed of it and the size of these particles. Also, we can color them from data layer. This means that we color the air temperature, or we could color by another setting here. Yeah, I think that's all for now, and this will be the end of the last session of these tutorial series, and I hope you will make some nice analysis and make it useful for our course. And if you have any questions, just post them. Alright.